Now in this example 1, we are asked to determine the magnitude of the resultant force along with the location of it from point A. Here the point has already been defined. That means we need to calculate moments with respect to point A. Firstly, you need to determine the magnitude of the resultant force and then location from point A. That means at which distance it is acting from point A. So these are the loads acting on AB beam. The loads are 5 kN, 6 kN, 7 and 8 kN. There are 4 loads. All are acting downward. So from here we can easily assume that the resultant will also be acting in downward direction. So here is the resultant R. Firstly, we need to calculate the magnitude of the resultant. In order to calculate the magnitude, we know that the formula is R is equals to root over summation of f of x square and summation of f of y square. So to calculate summation of f of x, let's see, is there any forces in x direction? No, there is no force in x direction, so the value will be 0. And for summation of f of y, we have considered upward direction as positive. So 5 kN is acting downward, it will be minus 5. 6 kN acting downward, it will be minus 6, minus 7 and minus 8 as well. From here we will get the value of summation of f of y as minus 26 kN. This is acting downward. So the resultant will be summation of root over summation of f of x square. The value of f of x is 0. Summation of f of y square, summation of f of y, the value of summation of f of y is minus 26. So minus, if we do the square of minus, it will be positive. So 26 square. So the value of R will be 26 kilonewton. So the resultant magnitude, or the magnitude of the resultant, is 26 kilonewton and it is acting downward. Here we can denote it over here with R. So this is the resultant R acting in downward direction, and the value is 26 kilonewton. Now let's consider this R resultant is acting at distance of x meter, as all the units are in meter. So it is acting at a distance of x meter from point A. According to Varigon, the moment that will be creating due to this resultant R will be equal to 26 into x. Here x is the momentum and this R is giving a rotation in clockwise direction with respect to point A. If we want to fix the point A, we can see that if we are fixing point A, this due to this R force, this portion of the beam will be rotating at anti-clockwise clockwise direction. So we have already considered clockwise as positive. So for resultant, the moment will be 26 into x. According to Varigon, moment of resultant force A, 26 into x, will be equal to sum of all moments due to the rest of the coplanar forces. So the resultant was generated from the coplanar forces 5, 6, 7 and 8 kilonewton. So the sum of the moments due to this 5, 6, 7 and 8 kilonewton will be equal to, for 5 kilonewton the moment will be 5 into the distance. Distance is simply the momentum. So 5 into 5, it is also acting clockwise, so it will be positive. 5 into 5. For 6 it is 5 plus 2, which is 7. 6 into 7. For 7 it is 5 plus 2 plus 4, and it will give rotation in clockwise direction. It will also be positive. 7 into 11. And for 8 it will be 8 into 5 plus 2, 7 plus 4, 11 plus 5, 16. So 8 into 16. From here we can see that the value of x is unknown. We can get the value of x equal to 10.48 meter. So we have got the magnitude of the resultant. We have got the location at which this resultant is acting from point A. This distance is 10.48 meter. In example 2, the problem is almost same. There is a bit difference. The third force is acting at a distance, is acting in as inclined. So as of being inclined, there will be a component in x direction. Let's see the question first. We are asked to calculate the or determine the magnitude and angle of the resultant force, and also the location of the force, resultant force. The location means at a distance at which the force is acting, the resultant is acting. So firstly, in order to calculate the resultant, we know the formula as summation of f of x square plus summation of f of y square and whole root of it. So let's calculate f of x and f of summation of f of y first. So for summation of f of x, it will be 40 is acting downwards, so there is no component for 40, it will be 0. So for 80 there will also be no component, but for this 50 kilonewton there will be two component, one will be in y direction and one will be in x direction. From our lecture 1, equilibrium of concurrent forces, we have already seen that how to calculate these components. So for this horizontal component or x directional component, it will be simply 50 into, here the value of the hypotenuse will be, as this is the base is 3, height is 4, the hypotenuse will be 5. So here the value will be 50 into 5 as denominator, and 3, as we are taking the horizontal component, it will be 3 as numerator. So from here we will get the value of the horizontal component as 30. So this 30 is acting leftward. We always consider rightward as positive and leftward as negative. So as this is acting leftward, we have considered rightward as positive. So for acting in leftward direction, it will be minus 30. So minus 30. So if we want to sum up the value of all forces in x direction or the component of forces in x direction, it will be minus 30 kilonewton, which is acting leftward. In same manner, let's calculate the y component first. For this 50 kilonewton, the y component will be 50 into height is 4, so it will be 4, and the hypotenuse is 5. Denominator will always be fixed, which is the hypotenuse. The hypotenuse is 5. From here we will get the value as 40. 40 is acting downward. Now calculating summation of f of y, we have considered upward as positive. We can see all the forces are acting downward, so all the forces will be as negative ones. So minus 40, minus 40, minus 80, 80 is acting downward, and this 40 is also acting downward. So minus 40. In total it will be minus 160 kilonewton. So the value of the magnitude of the resultant will be root over summation of f of x square, that means 30 square, and summation of f of y square, that means 160 square. We will get the value of the resultant as 162.8 kilonewton. So at which angle the resultant is acting? Let's see. In our previous example, all the forces were acting at a particular direction, that means in y direction only, no inclined forces. So the resultant was in y direction, but as here is an inclined force, the resultant will also be inclined. So we need to calculate the angle first. To calculate the angle, we know the formula is tan inverse summation of f of y by summation of f of x. Here the value of summation of f of y is minus 160 and summation of f of x minus 130. So the minus is cancelled out. So it will be minus. It will be simply 160 by 30. Tan inverse 160 by 30 is 79.4 degree. That means the resultant will be acting at an angle of 79.4 degree with the horizontal component, or the horizontal one. So the value of the resultant is 162.8. The value of the resultant is 162.8, and it is acting at an angle of 79.4 degree. So this resultant will have two component. One will be in x direction and one will be in y direction. The x directional component will be simply 162.8 cos 79.4 degree, If we want to see the value, 162.8 cos 79.4, we can see that the value will be 29.94. It's simply equivalent to 30 for y component, and for x component, and for y component the value will be 162.8 sine 79.4, as this angle is 79.4. So sine 79.4, 162.8 sine 79.4, the value will be 160. So we can see that the value of y component is 160. Basically, these two values are the same values as summation of f of x and summation of f of y. We have got the f of x as 30, is acting in leftward, so it will be 30, and here fy 160 acting downward. If we don't want to calculate using the angle, then we can easily write the values from f of x, summation of f of x and summation of f of y. These are the short technique, but it's better to calculate the component using the angles for better more accuracy. Now we need to calculate the location of the resultant. In order to calculate the location of the resultant, we need to apply Varigno's theorem. We know that by applying Varigno's theorem, we can get the resultant's location. So for resultant R with respect to point A, for R we have already got two components. One is 160 y component, and one is 30, which is x component. Let's write the value over here. The value of x component is 30. F of x is 30. So this 30 is acting through this A point. So there will be no perpendicular distance in between A and the direction of this 30. As this direction is towards A, there will be no perpendicular distance. This is acting through point A. Is there any perpendicular distance with this direction? No, there is no direction. But there is a perpendicular distance with this fy. This perpendicular distance is, let's assume the perpendicular distance x. So for this y directional component, which is the resultant one, the value of the moment will be 160 into the momentum x. So 160 into x, and this 160 is acting in clockwise direction, is giving rotation in clockwise direction. We are assuming clockwise as positive. So in left side we are taking the moment which will arise due to the resultant, 160 into x. In right side will be the sum of moments for all forces, rest of all forces. So for rest of all forces, what would be the moment? What would be the moment for rest of all forces? For rest forces, starting with 40 is acting at a distance of 3 meter from point A. So it will be 40 into 3. This is giving clockwise directional rotation. So 40 into 30 is positive. 80 into 3 plus 3, which is 6. And 40, for 50 it will be 40 y directional component we need to consider, as x directional component 30 have no perpendicular distance as well. Only 40 will have perpendicular distance, and the perpendicular distance will be 3 plus 3, 6 plus 5 is 11. So 40 into 11, the value will be, from this equation we will get the value of x as 6.5 meter. So we have already got the location. The resultant is acting at a distance of 6.5 meter from point A, and this is also acting at an angle of 79.4 degree with the horizontal, and the value of the resultant is equal to 162.8 kilonewton. So this is the conclusion, or this is the answer.